Okay, in the previous video on gross premium reserves from Contingencies and Actuarial Mathematics, I spoke about prospective reserves. In this video, I'm going to speak about retrospective reserves, and then in the subsequent video, I'll talk about recursive reserves as well as a special result. Okay, and also in this video, I'm going to relate retrospective and prospective reserves. Okay, so let's talk about retrospective reserves then. So for prospective reserves, what we did was, intuitively, we looked at what's to come, okay? And we reserved for what's to come. Remember, reserves are the amount that our insurer needs to set aside now in order to meet future liabilities. And so we did the expected present value of the outgo minus the expected present value of the income, and that was the reserves that we set up prospectively. Now, what does that mean then for retrospective reserves? Well, instead of looking forward, what we'll be doing is looking back. Okay, so we assume that life insurance contracts, or just insurance contracts, we like them to be self-funding. So what does that mean? That means that we set up reserves with the money that we receive from this contract, from the premiums. Okay, so we want this insurance contract to be self-sufficient. In other words, it should be able to meet all of its liabilities. Okay, now you might say to me, doesn't that defeat the purpose of insurance, of pooling things? So the idea is, no, it's not necessarily every single contract must be self-funding, but it must be that book of contracts, so that all the premiums collected from that book of contracts should be able to support whatever claims do come up from that book of contracts, in knowing that not all of them are going to claim. Okay, so retrospective reserves then, it's this accumulation now from these book of contracts. And retrospective reserves then is accumulating these premiums and accumulating the net inflow. Okay, so inflow minus outgo. This gives us our retrospective reserves at a certain point in time. Okay, so retrospective reserves then, defining it, is the accumulated value allowing for interest and survivorship of the premiums received to date, less the accumulated value allowing for interest and survivorship of the benefits and expenses paid to date. So this is premiums less benefits. So the accumulated value of premiums less benefits and expenses. Why? Because I received premiums, which is going to contribute to my reserves, and out of these reserves I'm paying benefits and expenses. Whatever's left over is my reserve at that point in time. So retrospective and reserves and prospective reserves, they both are calculating reserves. They don't calculate different things. Okay, and under certain conditions they will be equal, which I'll get to in a moment, but don't try and think these are different things. They're just different ways of calculating reserves, the same thing. Okay, so retrospective reserves then, accumulated value allowing for interest and survivorship of the premiums received to date, less accumulated value allowing for interest and survivorship of the benefits and expenses paid to date. Okay, fair enough. Now let's understand what this allowing for interest and survivorship actually looks like. So if I have any expected present value and I want the accumulated value, then how do I get there from expected present value to accumulated value? Well, I take my expected present value and I must then multiply by interest, compound interest for n years, to accumulate it in terms of interest. So that's simple enough. And this is the part that a lot of people don't understand. I divide out probability, and I'll explain why this makes sense. So NPX. Okay, so for a life-aged X surviving the next n years, this equals to my accumulated value. Okay, that's the relationship. So you can replace EPV and AV here with a lot of different things. So EPV, I'll explain this NPX by the way also. So I know a lot of you guys are questioning that. I'm going to explain it. So EPV, then let's say this was the contract, AX. Okay, then I can multiply this by 1 plus I. Okay, this wouldn't make sense because there's no such thing as a whole life accumulated, so I'll just say term, a temporary annuity, and that divided by NPX. This will give me S dot dot XN. Okay, so the accumulated one. All right, now in our calculations what we do is to get this accumulated value. I'm still going to speak about this, I haven't forgotten. In our calculations to get this accumulated value, we're actually going to work to the present, and then we're going to take everything forward by this factor. Okay, and that will give us this, and now, or the accumulated value in general. So then it's accumulated value of income minus accumulated value of outgo. Now you might say to me, George, why don't we just go straight for these formulae? Well, in theory you wouldn't be wrong, but you wouldn't be able to do it because the life tables don't have any of these accumulated values on it. They only have these present values, okay, the expected present values. And so in practice we just can't do this, okay, especially in exams. So this is the way that we need to remember all of these formulae. Okay, now by the way, this doesn't just apply for annuities. I could have swapped this out with an assurance with something, although there's no such thing as like a future value assurance really, but it would have been here the accumulated value for this. So the same thing really applies here, okay, but there's no such thing as like a future value assurance. It doesn't really make sense, but that's the symbols then that we'll be using. Alright, but the same logic still holds. Multiply by 1 plus I to the n, divide by npx. So now you want to ask me, why, George, do we divide by npx? Okay, there's a couple of ways that I can explain this to you. So the first way is by reversing the order of these operations and taking this to the other side. Then what I'll do is I'll have, so let's look at this here. So just generally with EPV and AV, accumulated value and expected present value. Now, my expected present value would then be equal to my accumulated value times by npx times by v to the n. So I discount in terms of interest, discount in terms of probability. So this npx in the denominator here is just as a consequence of this npx being here. So this is my discount factor, accounting for survivorship and interest. So discount in terms of the time value of money, but then also in order to receive this accumulated value, this person must survive to there, so I must account for the probability of surviving. And that gives me my expected present value. Okay, so that's how that works. That's that understanding. But let's take it, let's do another way, another method of understanding. That's a method that if you just want to remember this formula, I suggest you do that method because it's the simplest to understand. But this is probably a little bit more intuitive. Okay, so you might still ask me, so why then still is this npx make sense on this side? We know why it makes sense on the other side. Why does it make sense on this side? Okay, well, think about it like this. npx is equal to lx plus n over lx. Okay, so then I'm taking my EPV times by Vn times by that is equal to the accumulated value. Okay, and this should actually reverse the numerator and denominator. Why must I reverse the numerator and denominator? Because npx is in the denominator and npx is lx plus n over lx. So bringing that to the numerator, it's 1 over. So I take the reciprocal. So I get this. Okay, that should make sense to you. Okay, now why does this make sense? Well, because at the current point in time, I want to move from the current number of people to this future number of people. Okay, so what I'm essentially doing then is if I'm expecting there to be less number of people in the future, but there's more number of people in the present. So then I take this expected present value and I multiply it by the number of people that are alive right now. Okay, so that'll give me the fund value for everyone. But then at this future value, I need the fund value again for one individual, but there's going to be a fewer number of individuals alive. So I divide this fund value between the Lx plus n surviving individuals. Okay, so that's the understanding. So right now, the EPV, this is EPV per contract. So this is the number of contracts at the start, aged X, and this is number of contracts where I want to accumulate to. So if I take this per contract and I multiply it by the number of contracts now, and then I divide it out by the number of contracts at the end, which is going to be less contracts, some people would have died, then I'm basically increasing it. Okay, because I multiply by a big amount and then divide by a smaller amount. So that's multiplying it, it's increasing it, or dividing by a decimal. Okay, dividing by a decimal is like multiplying by a number greater than 1. Okay, so I hope this makes sense. If it doesn't, leave a comment, I'll try to tend to it. Okay, but I think I've explained that well enough. Okay, now, yes, so I've said that there's no actuarial notation for the accumulation of assurance benefits. Why is that so? Because it doesn't make sense. Okay, so assurance benefits, you can't really accumulate them because the contract's either going to die or it's and go out of there's no longer going to be a contract, it's going to terminate, or it'll be at the full value at the end. So it doesn't really make sense to have this accumulation of assurance benefits, but it's still a concept that we need to deal with. And so all accumulations will be calculated with EPV times by this to accumulate in terms of time value of money, and this dividing out the probability to accumulate it in terms of the probability of survival. All right, so that's good enough. Now let's look at a particular type of contract. What is this retrospective reserve? So TV retro for let's do a whole life assurance contract. So this will be 1 plus I to the t, because the reserve at time t, so I must future value 2 times t, and then I must discount or take out this survivorship discount. Okay, so divide that out. Okay, so accumulating in terms of time probability, and that should be a t there. Okay, and in here now it's the accumulated value of income, or now it's the present value of income minus the present value of outgo. And the reason why I'm saying present value in here is because here I make it accumulated, here I make it the future value, but inside here it must be the present, because that's the things that I have from the life table to deal with. Okay, so it's gross premiums that I'll be receiving, let's say monthly. Okay, minus, so this is my income, present value of income minus present value of outgo. So outgo consists of my benefits minus, and I'll explain all of this once I've finished writing it, the initial expense minus the renewal expenses, and then also minus this terminal expense. Okay, now you're saying, George, you told me this is a life assurance contract, but why now do I have temporary annuities and term assurances? How is this a life assurance contract? Well, this is a retrospective reserve calculation, so up until time t. So I'm looking at everything that I've accumulated from the start of the contract to now for t years. So I've accumulated t years worth of premium. That's why it's a temporary annuity. The benefits that have been paid out has this expected present value for term assurance, even though I'm dealing with a whole life assurance, because I'm not actually looking forward into the rest of this infinite term of the contract. I'm just looking at what's gone from time 0 till time t, retrospectively. That's why it's called retrospective reserves. Okay, then minus I, fine, we understand that. And then here again, the reason why we have this temporary annuity, same reason as this. Reason that we have this term assurance, same reason as this. Okay, and then by the way, all of the specificities here, like M or in advance or like payable immediately on death, all these different types of things can change depending on the wording of the question and the type of contract. Okay, simple enough. Now let's try and figure out when prospective and retrospective reserves are equal, and let's look at the conditions for equality. Okay, one thing's quickly come to mind, so before I do that, I want to explain this. Now, you might say to me, with my prospective reserves, they're nice because what I can do with them is I can look forward into the future and I can set reserves at the start of the contract at time t. But if I'm doing retrospective reserves, t is 0, I would have received no income and I would have paid no expenses. So my retrospective reserves at time 0 is 0. Yes, that's correct. They are 0. Because, remember I said, we're wanting these contracts to be self-sufficient, self-funding. that means that they pay out of all the income that they've received. So I have built up no reserves at time 0. Okay, so that's the logic. All right. Now, let's deal with the equality of prospective and retrospective reserves. So there are 2 conditions. Okay, that's terrible handwriting, but anyways, it's good enough. So condition number 1 is if the retrospective and prospective reserves are calculated on the same basis. So okay, that's the first condition. And then the second condition is that if this basis is the same basis that was used to calculate the premiums in the reserve calculation. So to calculate the premiums that I'm using in the reserve calculation. Okay, so this might not make sense to you, but I'm going to explain it now. Okay, now the reason why the reserves should be the same should be quite obvious, because if I use different reserves, then surely I should get different. If I use different bases, then surely I should get different reserves. So whether I do retrospective and prospective, I can't expect to get the same thing if I'm using different reserves. So the reserves, the basis must be the same. Okay, this kind of makes sense to us, but this might not make sense, and I'll explain why. Okay, so I'm going to explain why once I've started the proof for them being equal under these conditions, and it'll make sense to you. So actually just after the first line. So I'm going to show you that they're equal by starting with a type of contract, okay, where I calculate the premiums for that contract, so using the equivalence principle, and then from that I'll break those items in that contract, each term down, until I can get the formula for the retrospective and prospective reserves on either side of my equality sign, so that I can show that they're equal. So let me actually do it to show you what I'm talking about. Now you can choose any type of contract and show that this works. I'm going to choose a whole life assurance contract. So for a whole life assurance contract, I calculate reserves using the equivalence principle as such. I take my present value of my income, my expected present value of income, and I equate this to the expected present value of my outgo, which is the benefits, the initial expense, the renewal expense, and the terminal expense. So there's the terminal expense there. That's an F. Okay, this looks okay. There you go. So this is for a whole life assurance contract. Now the reason why 2 holds, or the reason why we need 2 in order for TV Retro and TV Pro to be equal, is because I need this equality to hold. And this is the equation that I use to calculate G. Okay, and if this equality holds, then the rest of my proof will follow. So I need this equality to hold in the first place, which is why the basis that must be used to calculate the premiums, which is the basis used in this calculation, must be the same basis that I'm using in the reserve calculations. And those 2 reserve calculations must have the same basis. And so I'm eventually going to get to a point where each reserve calculation is on each side. So the basis must be consistent throughout here, from this pricing approach all the way until the reserves. Okay, so that's why all of these 2 conditions must be true. Okay, so let's carry on and let's actually prove that one of these sides is a retrospective reserve and one of them is the prospective reserve. Okay, so what I'm going to do is I'm going to split the whole life annuities into a temporary and a whole life annuity, and I'm going to split this life assurance, this whole life assurance, into another whole life assurance, and a term assurance. So let me do that, and I'll show you, and you'll understand exactly what I'm saying. So this here can be split into AX for T years, still payable monthly, plus discounted by T years in terms of time and probability, a whole life assurance contract for the life that's aged X plus T. Okay, and then I've got to split this right hand side as well. Okay, so splitting the right hand side, I'll have S plus F. Okay, now I have to split this AX. So this AX will be split as follows. So I'll have AX T up until time T, a term assurance. Be careful to actually add this, otherwise it's wrong, because then it represents an endowment. We're not dealing with an endowment, this is a term assurance, okay? Plus VT TPX AX plus T, okay? And then plus this initial expense, and plus this, which will be split in the same way that I did here. So I'm not going to waste your time and write that again. I'll just copy and paste it. Okay. Okay, not going to fit. Alright. There you go. So, now I have all the terms that I need, but I need to bring onto one side my retrospective reserves and onto the other side my prospective reserves. Okay, so let's do that. Okay, so I know retrospective reserves look something like this here for my whole life assurance contract. So I need to get that on one side. So I need everything that has a temporary or term in it on one side. So I need this term here. I need G A X T for M years to be on one side. Okay, that's going to go on the prospective side. Then I need this to be on the same side here. So when I take this across, this term across, I subtract now S plus this terminal expense for AX, this term assurance here. Okay, and what else do I need on the side? Well, I'm going to need an initial expense here. Okay, so minus the initial expense. And then I'll also need this term here. So minus E A X T M. Okay, now everything else will go to the other side of the equation. So this equals to, now remember this term needs to go to the other side. So I'll have negative G. In fact, let me write this in such a way that it's going to be easier to work with later. So I'll start with this term over here. I'm going to have in here VT TPX into, okay, I'm going to take out all these terms, S plus F AX plus T bar. Okay, so that's that distributed into that term. Okay, I'm also going to need that one there. So I have this TV TPX out here, and then I need this expense and this term over here. So I need plus E A X plus T. Okay, and then I need this G and this one that I haven't taken into account. So then what happens when I do that is it gets subtracted when I take it across to the other side, and then this TV TPX will come out as this common factor, and I'll have subtracting G A X plus T. Okay, and then once again, okay, this should be M3, this should also be M3, and this should be M3. Okay, now let's just make sure we haven't left anything out. Okay, so have I dealt with this term? Yes, I have, it's over here. Have I dealt with this term? Yes, I have, it's over here. Have I dealt with this term? Yes, it's over here. Have I dealt with this term? Yes, it's over here. Have I dealt with this term? Yes, here. This term? Yes, here. Okay, so I've dealt with everything in this I also, yeah, okay, I've dealt with everything. So all these terms you can see have followed there. Now, I need one of these sides to be the retrospective reserve, one of them to be the prospective reserve. We know this is going to be the prospective reserve, this is the retrospective reserve. So let's go look at our retrospective reserve. It's, so far, on the left-hand side of the equation below, I only have this. I only have this here. What do I need? I need 1 plus I times by t and tpx. So I multiply this by 1 plus I to the t over tpx. And then this side, I must also multiply, because I'm going to do to the left-hand side, do to the right-hand side. So what happens is when I multiply by 1 plus I to the t over tpx, this tpx is cancelled, and this 1 plus I to the t cancel with the v to the t, because v to the t is 1 over 1 plus I to the t. Okay, so those all cancel. And now what I'm left with is tv retro equals to tv pro. Okay, and here I've proven that the equality of prospective and retrospective reserve. So here you can see that I have been calculating the same thing in both cases. The only difference is that the way that I calculate it. One looks into the past and takes all the accumulations from the net accumulations of this contract, and one looks into the future and looks at the potential losses and how much I must reserve for those. Okay, that's it for the video. Thanks for watching. I'm going to cover recursive relationship between reserves for annual premium contracts in the following video. Cheers.